Myself is Geetha. I am working as assistant professor in CSE. In today's session, we want to discuss about the pointers. See, pointer is a special type of variable in C. It is also one of the derived data type where pointer is used to store the address of another variable. Before going for the pointers concept, let us understand what is the address, what is a variable, that one. See, if you declare a variable as int a equals to 10, then internally in memory, some memory is allocated to the variable a with some address, for example 100. And here as we initialized with a value 10, a value is 10. If we use a printf statement, printf %d a, it will print the value of a, that is 10. If I want to print the address of a, then %d ampersand a, it will give the address of a. It will print 100. Now, here the special symbol ampersand is known as reference operator. Reference operator. Now, if we declare a variable int a equals to 10 and if I want to store the address of a, then we should declare one special variable known as pointer variable. So, pointer is a variable. Pointer is a variable which is used to store the address of another variable. Now we have seen only the definition of the variable. So how to define a pointer variable, how to initialize a pointer variable, and how we will use a pointer variable to access a normal variable, we'll see now. So here the declaration of pointer variable. See how normal variables are declared. Normal variables are declared as data type, variable name, semicolon. Similarly, pointer variable also declared as same syntax with one extra symbol, that is asterisk. So, how to declare a pointer variable now? Data type, pointer, asterisk, pointer, variable name, semicolon. So, here data type, asterisk, variable name, semicolon. Okay. For example, if I want to declare a pointer, integer pointer variable, then what is the data type of integer? Int asterisk a. Now, a is what variable? A is a pointer variable of type integer. So, is it clear now? Here we have seen now the concept declaration of a pointer variable. Now, how to initialize a pointer variable? How we have initialized a normal variable? The initialization is done as variable name equals to value. So similarly here, if I have a variable int a with some value 10 and I have declared one more pointer variable p. Now I want to initialize this p. As p is a pointer variable, it will store what? It will store the addresses. So now I'll assign p with address of a. So this is known as declaration and this is known as initialization. Now see, if we have like this, int a equals to 10, int pointer p is equals to address of a. We can also initialize a pointer at declaration itself. How internally it will store means, as soon as we declared a two variables, it will occupy some space in memory, a and p. A also have one address and p also have an address. Now what a value is having? 10. A equals to 10. What is p here? We are assigning p with address of a. Then p contains address of a. Address of a is nothing but 1000. Now here a gives 10, address of a gives 1000 and p also gives 1000. Now here asterisk is nothing but one name it is having, that is dereference operator. Why it is called as dereference means, for example, if you print like pointer p, pointer p means pointer address of a. It indicates that value at this address a. So what is value at the address a? Address a is nothing but 1000. Value at the address 1000 is what? 10. It will print 10. That means it is going to the reference. At that reference, what value is there? It is printing. So asterisk is known as dereference operator, whereas ampersand is a reference operator. And this asterisk symbol, that is a pointer symbol, is known as dereference operator. Now we'll see how pointer is working on how the address of the operator, whether the pointer p is giving the value of a or not. We'll check now. Now we'll check how it is going on. stdio.h void main. So here write some small program that demonstrate how the pointers and normal reference and dereference operator is going on. So we declare one variable here a with some value 10 and one pointer variable int pointer p. Okay. So here p equals to, I am assigning the address of a. Now if I print here printf value of a, normally while printing the statement it will give, so this statement will give 10, right? Now I want to print the address of a, then for address we'll use a control string %u. Address of a is %u, comma, for address dereference reference operator ampersand a. Okay. So now here this will give address of A. We'll see whether it is giving or not. So here I kept the semicolon like this. So see here, the statement value of A is equals to 10 and address of A is equals to 6422168. Now we have printed the value and address by using A's. Now I want to print these two things by using a pointer variable P. So if I write here printf address of A is percentile U. Here what you are using? You are using P, comma P. Value of A using P is, here value of A I am printing by using the P variable. See, for every statement we'll keep a next line so that it will be. So using P, you are printing the address of A, it is printing same thing, and value of 10 is also printing. Like this, by using the pointer variable, we can access the normal variables. So to print the value, we'll use the asterisk symbol. To assign the address, we'll use the ampersand symbol. This is a very introduction to the pointers. Now we'll go somewhat deep into the pointers. So the declaration completed, initialization completed. Now one more thing I want to explain here. See here. See, I have now two variables, int A and one pointer P. Now if I take P is equals to address of A, it is applicable. Similarly, it's same thing, int A, pointer P, char C. Now if I want to assign P is equal to ampersand C, it won't take. That means a pointer can hold address of another variable with corresponding data type. Corresponding data type. Now see here, if integer pointer can hold only address of integer variables. Character pointer can hold address of character variables. Similarly, float can hold only float, double can hold only double, like this. Now, So what's the use of pointers means? Pointers always access through memory locations. If it is access through memory locations, so that execution speed increases. Many data structures are implemented by using pointers. Next, here pointers are efficient when working with arrays. Pointers improve the system speed. So due to this, these are the benefits of the pointers. Now we'll see the compatibility of the pointers. Now hash include see, I have one variable int a and one pointer variable p, and I declared one variable char c. Now for p, I am trying to assign the address of c, and I am trying to print here printf percentile d pointer p. Pointer p. So here what variables we have? We have one a normal variable a of type integer, one pointer variable p of type integer, and one character variable. But integer pointer variable, here we want to assign the address of character. We'll see whether it is accepting or not. See, we have one error here, assignment for incompatible pointer type. So, it is an incompatible pointer type. So, we should not use like this. Always integer pointer should point to integer and character pointers to point to character like this. So, up to now, we have seen the declaration of a pointer variable, initialization of a pointer variable. Now, we'll see how the scaling factors of the pointers will act. Scaling is nothing but, see, we initialized a with some 10 and pointer p. Like this we have. You know, I am assigning address of a. Then what p will give? 1000. And pointer p will give value 10. Now here if I write p plus 1, that means it won't give here for 1000, it won't add 1, it is wrong. It won't give 1001, it is wrong. It will give the next memory location 1002, because here a is a int type, it will take 2 bytes to add for the next location. This is known as the scaling factor. This is a scaling factor on the pointers. I'll show the execution here. Now, here I am giving p is equals to address of a, right? If I print p, what it will print, we'll see first. It printing some address that is 6422168. 6422168. Now, if I make an addition to the P, P plus 1. Then if I execute this one, so in order to differentiate the previous one, we'll make slash. So what you are doing, you are printing P plus 1, we'll check whether it will increment by 1 or whether it will increment by 4. See, it is 68 previously, and for that you are adding 1. 1 adding means 1 location you are adding. For each location how many bytes? 4 bytes. So 68 plus 4. Why it is 4 bytes? In their C++, integer will take the 4 bytes of memory. So 68 plus 4, it will give the 72. This is known as a scaling factor of the pointers. We have so much flexibility with the pointer. We will see in what way it is more flexible. A single pointer can points to multiple locations. For example, X, Y, Z are there. We can declare a single pointer P1 and we can points to X, Y, Z. For example, like this, int X, Y, Z, and one pointer P1. Now for P1, I can assign X. For P2, I can assign Y. For P3, I can assign Z. Okay. Now, this is one flexibility. One more flexibility is pointer flexibility. Here is multiple pointers. These are pointers. Multiple pointers can refers to same memory location. This is the pointer flexibility. So today we completed here declaration, initialization, and how to access the variables using pointers. In next class, we'll continue about pointers and functions, pointers and arrays like that. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.